Good morning, everyone. So I've been asked to come along and talk about mid-rise timber buildings and sort of fire issues. So I'll talk about the fire regulations and general specifications. My name's Boris Iskra. I'm the National Codes and Standards Manager at Forest and Wood Products Australia. As part of my role, I basically handle anything that's sort of half technical. Will cross my desk, anything from fire to structural to durability to whatever. So I've got my fingers in a lot of different pies. So I'm sort of across most things. How they make that expression, I've got a lot of knowledge across a whole range of things, but I wouldn't put myself as a key expert in any one. But obviously I've done a lot of work in the building code regulation change space. That was one of the programs that I undertook under Forest and Wood Products Australia. So I'll go through a little bit of that work. So I think what I thought that I would do was basically run through a bit of the work that was done in terms of the development of the National Construction Code and the ability to build taller timber buildings. I'll talk about what the provisions are, and so what can we currently build under the I suppose the DTS provisions, the deemed to satisfy. Talk about the Wood Solutions program and the design and technical guidance that's provided. That's a program that Eileen Newbury manages. I'll run through just some case studies of some performance solutions that are out there, and talk about the challenges that are faced, particularly when we start to have these larger exposed timber buildings, sort of the issues that come up. I'll just call them challenges because they're not insurmountable, but they're just things that we need to do. And then look at what sort of the next steps are from an industry perspective as to where we'd like to move going forward. So just looking back as to where we've come from. So in early 2013, there was a program commenced at Forest and Wood Products Australia, looking at what was the opportunity for us to have mid-rise timber buildings here in Australia. A colleague in that photograph on the right-hand side, that's in Canada. He sent me this photo just as we were starting the program, saying, look what they're building in Canada. So there's a 6-story apartment block there, and we weren't able to do that under our code. So it was, I suppose, also industry was saying, we need to look at what's happening overseas, and at that time was trying to catch up with what was happening. So Forest and Wood Products Australia basically engaged with various stakeholders. As part of trying to achieve any national change, we need to engage with key groups such as the national regulators. So we had sort of meetings and discussions with the Australian Building Codes Board as to what we were trying to achieve, and just trying to get some guidance from them as the sorts of things that we need to address, and people we need to have discussions with. We spoke with every state government building authority around the country, so we had face-to-face meetings. Really, at this point, it was really just understanding what the issues were. What were the technical issues that would stop us from going beyond? At that time, we were able to do 3-story apartment buildings, and what was stopping us from going beyond that, and getting the feedback from the various stakeholders. So we also met with all the state fire authorities. Again, these were face-to-face discussions, a presentation showing them what we were trying to achieve. But in the first instance, again, just understanding what were the barriers and what were the challenges that we need to address. And again, we then engage with all the professional associations, from the master builders, I suppose, a key group in that commercial space, the fire safety engineers, etc. So this first part of it was all about understanding what the issues were from the stakeholders, because you can't achieve a code change with responding to issues and understanding what those issues are. At the same time, during those discussions, we started the work on what's called a proposal for change to the National Construction Code, or the Building Code of Australia, whichever way you like to refer to it as. So we started a proposal for change development. We're also undertaking doing some research in that space. So we're drawing on not only what we're doing in Australia, but we're looking overseas. We're looking at what was permitted, looking at various fire tests that had been undertaken and trying to draw on that information in terms of trying to support the establishment or achieving a code change. Now, one of the key things, and I suppose fire is a key topic for today's discussion, one of the early things that was raised was fires in timber buildings. So there was a design guide that was developed looking at fire precautions during the construction of large buildings. You'll note that there's no mention of timber in that title. Basically, when we're looking at the issues, fire's an issue regardless of the material of construction. You can have fires on site. Obviously, with timber, when it's an exposed element during a construction phase, before you have your other fire measures or protection systems in place, it's probably the most critical point. But once all those systems are in place, the buildings are extremely safe. So this guy basically talks about addressing those fire precautions that should be considered during construction. And that was a commitment that was given to the Australian Building Codes Board at the time that we would produce such a guide and release that to the market. So that was done. So based on the work, and it sort of sounds fairly quick, but it was a lot of very intensive work over a couple of year period. A submission was submitted, or a proposal was submitted to the Australian Building Codes Board and the Building Codes Committee, the technical committee, for review, and there was a change was achieved. So in NCC 2016, where we could build class 2, 3, and 5 buildings. So class 2, basically apartment buildings, 3 hotel motel style developments or buildings, and class 5 are office buildings. Now, what this change was all about protecting. What the term that was introduced was fire protected timber. Basically, our timber elements are protected by fire grade plasterboard or some sort of fire protective covering. That change enabled us to go up to this, what's termed under the NCC as a 25-metre effective height, typically in an apartment building, it's like an 8-storey apartment building. So at that time, that was, I suppose, I'll use the word almost like world leading. We've gone beyond the North Americans. Unfortunately, they've gone beyond us now, which I'll get to towards the end of the presentation. So following that change, which is specific to 3 types of building classes, further work was done, some additional fire engineering analysis, some full-scale fire testing, and a following submission was made. So in the NCC 2019 was amended that we could now build any class of building up to this 25-metre effective height using full timber construction. One of the, I suppose, little tweak changes that was made in the NCC 2019 edition, the definition for massive timber originally talked about the use of glues as a requirement, but there are building systems that can be done without glues using timber, such as the bottom left-hand side, just using screw fixing techniques to laminate your timber elements together to form a mass panel. Or in Europe, they use timber dowels to pull together panels of timber. So the definition was changed to remove the words of requiring adhesive. So as long as you meet this minimum thickness of 75 millimetres, you can put together a panel using any type of fixing, be it glues or screws or dowels, to make up these massive timber elements. And I think the key focus of the group today, or the discussion, was going to be about mass timber. So that's why I've sort of introduced this as well. So there's options under the National Construction Code that can be used. So now we've got NCC 2022 coming in out of the 1st of May. There's no further changes to the provisions for fire protected timber. So we can still build up to that 25-metre effective height under the NCC 2022. One of the things I wanted to talk about, and this is where I suppose the discussion tends to happen when we talk about mass construction, as to a pathway. So under the NCC, there are two typical compliance pathways: a performance solution, which is where you're not following a recipe, you're just going down and you're doing something that's a bit different to what the National Construction Code gives you as a recipe of compliance. And that's the way a lot of these exposed mass timber buildings, well, that's the pathway that they've gone down, is using a performance pathway, and I'll talk a bit more about that later. The other pathway is what the code change was all about, was coming up with a deemed to satisfy solution. And as part of that, we also gave a commitment to the Australian Building Codes Board of providing technical guidance to the market as to how these buildings were to be constructed in compliance. And so there's a suite of design guides that are in the market that go through all that detail. So as I mentioned, as of 2022, there's really no change. But when we talk about classes of buildings, it's easy to just rattle off. All classes can be built using timber construction. Literally, they're the classes. So you could even build a car park out of fire protected timber if you chose to. It's interesting when we're doing our code change work. We're looking at car parks in Sweden that are built out of mass timber. With fully exposed. So there are examples around the world where people have built these sorts of buildings, i.e. car parks, using timber as well. But I suppose the opportunities are there now as under the deemed to satisfy. So to build each of these classes of buildings out of timber. Now, what's I suppose the key provision? Basically, you won't see any of the timber under the deemed to satisfy pathway. So the term is fire protected timber. And as I mentioned earlier, the timber is protected by some sort of fire protective covering. Now, I suppose the key to the change is that top line where it says fire protected timber may be used wherever an element is required to be non-combustible. So there are some elements in buildings that the National Construction Code deems must be non-combustible. And in effect, that then stopped any timber from being used unless you went down this performance solution pathway. So the way to address that was this fire protected timber solution basically now enables us to use a timber system wherever the building code requires non-combustible construction. I know there's been talk about timber on external walls on buildings, and there's been discussions around the world about the ability to use timber in that application. Under our National Construction Code, we can. So under the deemed to satisfy pathway, we can put timber construction throughout the entire building, even if an element is required to be non-combustible, based on having the timber protected by fire grade plasterboard, limited to this height of 25 metres, which is measured to the topmost floor in the building. You've got to have a compliance automatic sprinkler system throughout the building. Any insulation that's put within the walls needs to be non-combustible. And with our lightweight systems, where you can have cavities between walls, so if you've got fire rated walls for one apartment and the adjacent one, to minimise fire going up between cavities at every top and bottom of that wall, we'll have a cavity barrier. So sorry, I've gone into a little bit too much detail, but just to say that there's logic behind the way things have been done. So basically, under our fire protected timber systems, we have our lightweight option using fire grade plasterboard, or our massive timber systems. So I know there's a little bit of a juggling of words. Under the National Construction Code, the term is massive timber. We may look to change that. I think the common vernacular these days is mass timber. But at the time, we're just trying to use the word that said this isn't just sticks of wood. they're massive bits of wood, so we use the term massive timber. But look, it's just it's not a big deal, but just sort of point that out. So again, you've got these fire grade linings and the automatic sprinklers are the key sort of features of the construction.
Boris, I think we just got a question, if that's all right, Jeremy.
Can I ask a question, Boris?
Yes. Yeah.
Just to clarify the definition around fire protected timber, in regards to mass timber elements, does fire protected mean that the timber element underneath does not experience any char for that FRL, or does it have to, or can it start to experience degradation of that fire grade plasterboard after say 30 minutes or something like that?
Yeah, look, thanks, Jeremy. Look, good question. I was going to just say, Stephen, I can't sort of see everywhere on the screen when someone speaks like now. Jeremy's popped into my visual. So yeah, if someone puts a hand up, please just happy to take questions during the presentation by all means. Look, under these fire protected timber systems, there's a requirement that the plasterboard provides protection to the substrate, to the timber element, for a required period before charring may occur. So for lightweight systems, basically that's 45 minutes during a fire test. For cross-laminated timber or a mass timber element, that's reduced to 30 minutes. So you may experience some charring, obviously, after that time. And the temperature for a mass timber element for that 30-minute period can't exceed 300 degrees C. So that's the point of charring. So the reason it was done that way was to give us some additional protection, so as to limit the temperature rise at the interface between the plasterboard and the timber element. Because mass timber, there's a lot of wood there, and there's a bit of a concession, I'll use that word, given to mass timber because we're using the inherent fire resistance. So large bits of wood have natural fire resistance, and natural because the timber chars and provides that additional protection. So if we're looking at, so fire protected timber is that one pathway. When we start to talk about exposing timber elements, we've got a design procedure in our engineering standard. So AS 1720 Part 4 gives us an ability to use the char as part of the designing for fire resistance for that element. So thinking a column, we can design that column to sit there for 90 minutes based on the charring rate, and our engineering standard allows us to do that. So yeah, there are two, we need to be clear when we talk about fire protected, it's all a system, and that's the way it's built. You can't pull away some plasterboard away to expose an element under the current provisions and automatically comply. If you're wanting to remove some plasterboard, you'd have to engage a fire safety engineer to look at the impacts of doing that. I've heard people say, geez, that's a very conservative approach, and why is it done like that? We want to see the timber. And I go, look, by all means, I understand that. At the time when we were trying to get a code change, you weren't permitted to use timber. The requirement was it had to be non-combustible. How do you convince all the stakeholders that you have a system that will be equivalent to a non-combustible element? So that's why the pathway was taken to protect the timber in that first instance. And I'll sort of preempt what I'm going to say a little bit towards the end. We're now at the point where we can say, let's now look at what we can start removing from our deemed to satisfy provisions in the code without impacting on the overall life safety and structural safety of our buildings. So that's where we are heading.
Thanks, Boris.
Yeah, no worries, Jeremy. Thanks. Yep.
Christina, you got a question?
No, sorry, that's not my hand. I think it's Simon.
Oh, okay.
Sorry.
Okay.
Yeah. So I think it's my turn. Boris, quick question for you. So has there been much uptake of the deemed to satisfy solution, or is it still mainly engineered designed?
Look, there's been sort of, I'll use the word sort of combinations of things. The one I think, and I probably might be corrected, but there's a building going up here in Melbourne out at Collingwood, they're using protected systems, but it doesn't actually meet within our building limit, because like 8 stories, the one in Collingwood, from memory, I want to say 13 stories or 12 or something. So, but they have used in effect, fire protected systems, but it's sort of a performance solution. Like it's a combination. So they've used protection, but they've actually gone beyond what the code says you can go in using fire safety engineering design. There's a building shot I'll show you in a moment when I go through some examples. There's a 5-story building here in Melbourne as well, which is all lightweight timber frame construction. It was actually built before the code change happened, because I clearly remember there was an issue with the fire protection that we were proposing. I mean, I don't want to sort of bore you with the details, but we under the code as well is that even though and let me just quickly run through this, Simon, and I'll get back to the point I was going to make. So the approach with this, basically the design principles, or the fire design principles, are that we're using the automatic sprinklers as our first line of defence to suppress the fire in the event, to minimise the chance of the structure being impacted. But as part of the analysis, we do assume that the sprinklers won't activate in a small number of cases, and that's based on statistics. So we have actually looked at that, and that's why we need this this level of protection from the plasterboard to give us that ability to resist fire in the event that the sprinklers don't activate. So we have looked at that. Then we use the fire-grade plasterboard in effect as our second line of defence. And that's in that, as the words say, in the event that the sprinklers don't activate. The cavity barriers are to give us some additional protection in case there's a breach through the plasterboard. And then we also, if there is a breach, in the unlikely event that there's a breach for some reason, the insulation is non-combustible, so it doesn't cause us potential fires within any cavities that might be present, such as that third image down of the CLT with insulation between the fire-grade plasterboard and the CLT itself. So if there's a cavity, we would use a non-combustible insulation, just in the event that somehow fire got in there and didn't race up a building. So I think, sorry, Simon, I don't know if that answered your question. Just trying to think through that, but if not, we can pick up on that later on. Simon, you can just remind me if I've missed something there. So these are lightweight systems. I won't spend a lot of time. So these are systems that are being used. People ask me the question: are the DTS provisions being? Oh, sorry, that was your question, Simon. I had a fellow probably about 8 months ago from WA call me up saying, I'm designing a 5-story lightweight apartment building. I want to use the deemed to satisfy provisions. I just got some questions about the fitting of the cavity barriers and things like that in a response to a certifier. So certifiers are still looking very closely at timber buildings, but is just wanting to respond to that. So there are examples. The difficulty I have is only here when there's a problem, and I get involved in that. I don't sort of see the range of buildings that are being done or being completed. Although Wood Solutions has now got a database of timber projects on the Wood Solutions website, so you can actually start to see the types of buildings that are being built, which is a great initiative from the Wood Solutions website. Now, in terms of the mass timber element, so as I mentioned, it's a minimum thickness of 75 mil and that fire grade plasterboard. So we know, once you've got, if a 90 by 45 fire protected timber system can work as a wall stud or wall system, a large continuous panel of engineered wood product has an even more ability to resist that fire and enhance the fire performance. So that was basically the logic, and having a minimum thickness was based on structural views or analyses that were done just to give us a minimum performance, not only from a fire as well as a structural perspective. So as I mentioned earlier, we've got a range of design guides that cover off on all the classes of building. And these are basically being almost utilised by the marketplace as the guide, well, not only guidance documents, but you'll have certifiers asking for details in accordance with the design guide. So they're coming up to having the Wood Solutions brand has a very strong status in the market, and these design guides are viewed as I suppose the go-to type documents. So yeah, that's looking at all protection of our systems. But looking at the NCC, and this is something we're doing, working through at the moment, it is possible to demonstrate compliance with the NCC by using exposed mass timber building elements. And there's a presentation on this in itself that a colleague of mine's pulled together, Andrew Dunn, that is. So basically looking at you need to identify the type of construction, and under the National Construction Code, we've got three types, type A and B, which are at the higher fire resisting end, and type C construction is typically timber framed construction. Within type A and type B, the taller you go, you move into these higher, sorry, you need the type A construction when you get above a 4-story provisions. Then you also need to look at where the non-combustible provisions kick in. So there's a clause, I won't go specifically into that, but there are specific elements that are required to be non-combustible. Then there are other provisions within the NCC that talk about the transfer of non-combustibility provisions. So if you've got a fire-rated element at one floor, that element needs to be supported by an equivalent fire-rated element. And so this is where all the discussion starts to happen with certifiers, and this is where the difficulties start to get raised. And this there are concessions within the NCC about under this support of another part that need to be considered. And there are some elements basically where if you still can't meet via these concessions or these other clauses, and you're still required to be non-combustible, then you need to look at fire protected timber elements if they're up to that sort of 25-metre effective height, or it could just require concrete masonry construction under the NCC. So this gets complicated, which is what causes a lot of the discussions. But a good summary that was provided by Andrew, basically saying that if you're looking at non-combustibility provisions, it's basically external walls, these common walls, non-load bearing shafts and non-load bearing fire resisting internal walls, but also floor pits in lifts, lift pits with the floor framing and flooring. But this example building here, you need a non-combustible facade or the non-combustible lift shafts. But there are no sort of non-combustibility requirements on the floors. You just have a fire resistance level you need to achieve. Columns, the same thing. Beam elements, and you don't have any fire on external walls. You're not having in effect an external wall. You've got an element such as in this case bracing. It's not contained within that external wall because we've got our facade. You could basically say that bracing element also has no non-combustibility requirements. So you can argue through the NCC that you can actually come up with a solution using exposed timber construction. You need to get the certifier as part of that discussion to take that through. And so when we start talking about exposed mass timber buildings, you end up going down this performance pathway because of these difficulties or disagreements in the way the NCC is being applied. I don't know, Simon, if that's a question from you.
It is. Is there any work being done on recognition of fire retardant treatments?
Look, fire retardant treatments can, they can be used for certain elements but they need to be impregnated from, this is for fire hazard indices.
Yep.
So that's sort of spread of flame or ignitability or smoke develop. You can do it, but it's got to be impregnated in the wood. From a fire resistance perspective, I know there are companies working in that regard, but I don't know of any solutions.
Yep.
I don't know if there's anyone on the call that might have some, but I'm not aware of any. But you'd have to obviously demonstrate that the fire retardant achieves the fire resistance level, so you'd have to do a full-scale fire test to demonstrate that. But I'm not aware of any products in that regard that are being used or have been used.
Yeah, I understand they're recognised overseas or in certain cases. So maybe it could be a nice little research project.
Yeah, look, I have spoken with companies that have sort of fire retardant coating systems who are doing work in this space. I've seen them at lower fire resistance levels, let me call it, say, around 60 minutes. I haven't seen anything up to the 90-minute or 2-hour, so 1.5 or 2-hour fire resistance levels, which is what you end up needing at this sort of building.
Yep.
But I know there's a lot of interest in doing something in that space. One of the difficulties with fire retardant coating systems, and I've had this discussion with the Australian Building Codes Board and the technical committee, the Building Codes Committee, just trying to get us to be able to apply a coating system to a wall that has to achieve a certain group number, for instance. And the comment sort of comes back is, yes, but how do we ensure that doesn't get damaged over its life? How do we ensure no one does something to it, such as over paints with paint systems that might denigrate the performance over time? And so it gets difficult. I don't think it's insurmountable. I think we should be able to do that. We allow us to put coatings on steel construction,
absolutely,
to fire resist. I don't know what the requirements are for checking how good that resistive coating is working over 20, 30, 40, 50 years. Is anybody checking that it's still in place? I don't know. Those sorts of things. I can be cynical, but I'll focus on the timber side.
Boris,
yes.
Boris, sorry to interrupt. I just want to be cognizant of time.
Yes, sorry.
Not sure how much you've got left in your pack, but maybe 5 minutes, and then we'll just do any final questions because there's a few other items to go through. Thanks.
Sorry. Okay, no worries. I've taken too much time. Sorry about that, Stephen.
That's all right. It's all good topic.
So,
it's all good stuff.
Look, I'll go through these slides. I'll scatter through these a little bit quickly, just about the performance solution. So there's a few steps when you start talking about mass timber buildings. The approach has been the performance solution pathway. So there's a range of things that need to be undertaken to do a performance solution. And some of the key things, you got to do this design, performance-based design brief. You got to work with your stakeholders. So you get your fire brigades, you get your engineers, everyone involved. You sit around the table and you come up with a performance-based design brief. You got to do your analysis to that. So there's a lot of steps, which is, I think, one of the things that puts people off going down a performance solution pathway, even though the building regulators want people to be going down this pathway. So just a few examples of sort of performance solutions that have been done. I suppose Lend-Lease was one of the first here in Australia, with the top right hand image there showing exposed timber element within the room, but there's a lot of protection otherwise, plasterboard protection provided in that building. Then we've got fully exposed library out at the dock here in Melbourne. So got beams, columns, floor plates throughout. The International House, again, Lend-Lease has been a real driver in pushing down this timber options. So a really beautiful building there. Here in Melbourne, again, a 10-storey apartment building put over a 6-storey concrete podium. So basically got a few extra or 4 extra stories because it did go timber as opposed to doing a traditional concrete extension. The fully exposed, another beautiful building up there, up in Brisbane. And now we've got the T3 example here in Collingwood with a timber building. throughout.
What's the timber? How many timber stories is that one?
It's got that. I think it's a 10-story above the substrate. I can't quite remember. It's an overall 15-story with those. I think that's more like an office complex and apartments above.
Gotcha.
Like I say, I'm a little bit removed from that building. Had some early discussions from a fire perspective, but that once those discussions are over, I tend to get back out of those.
Yeah.
So there's another colleague who'd be all over that, and I know there's been some site visits done recently. And then the Atlassian building, they're talking about a 40-story tower being done in Sydney. So there are people really pushing the bounds and people really keen, and this is all being driven by sustainability. People want to build in timber for those benefits. And I suppose that one of the comments I was wanting to make was now with the Olympic Games in France, where basically half of their buildings, the public buildings, need to be built out of timber. So there are people wanting to do build using timber construction for environmental reasons. So what are some of the fire challenges? I talked about performance solutions and having to engage with people. That's one of the things that sort of is a challenge still with mass timber, is just increasing the understanding of building professionals. And so design guides, seminars, webinars are all that to try and engage. Demonstrating the fire performance of exposed mass timber elements. So a lot of work's been done in that space, with fire test reports now being available through major manufacturers of timber elements. The adhesives issues been raised time and time again, and there's full-scale fire tests that have shown the performance of these new adhesives that can be used. And also connections are the other one. So you've got exposed elements, you've got a column and a beam. How do you detail that junction? And there's been full-scale test work that has been done looking at a range of different types of connectors and ways to protect those connectors. So it's not the timber that's the issue, it's the metal in that connection that becomes the issue. So what are the next steps? This is what the North Americans can do. So they've, through the International Building Code, that's got 2012. They've got a 2022. I've got that wrong image on that, but that's when it first started with the introduction of different types of timber systems. So fully encapsulated systems, they can go up to 18 stories. They've got exposed building elements with some or limited exposure. They can get up to 12 stories. Fully exposed timber buildings, they've got up to that 9 stories. And they've always had this heavy timber construction, so sort of like the old 200 by 200 columns. They can go up to that sort of 8 stories. So from an Australian perspective, we're looking at what's happening overseas and saying, geez, it'd be great to be able to do some of that type of building here in Australia. And that's what we're working towards, to try and open up the opportunities for a bit more exposure in mass construction. So from a timber perspective, what's old is new again. So you got in Perry House in Brisbane, built in 1913, post and beam construction. That's now been converted to apartments, and we're doing post and beam construction in 2018 with the 2025 King. So yeah, we've done full circle. So I'd like to thank you for your time. Happy to take any further questions.